All right, let's just jump right in. We're totally bypassing the basics today and plunging straight into the deep end of how artificial intelligence has completely rewired the 2026 educational landscape. And look, we aren't just skimming the surface here. We're going to explore this in 3 dimensions, literally peeling back the layers from the individual classroom experience all the way down to the gritty global supply chains actually powering it. Just listen to this quote for a second. My prep time dropped from 3 hours to 30 minutes a night. I'm getting my life back. That's from Michael, a high school physics teacher. I mean, we talk endlessly about big data and algorithms, right? But this is the immediate human result. Hours of grueling, repetitive lesson planning condensed into just 30 minutes. Teachers can just upload static problem sets, and platforms like Nearpod instantly generate these interactive step-by-step lessons. It's wild. This is our tangible entry point into this 3D exploration.
Layer 1, the AI-powered classroom.
So at this surface layer, the day-to-day tools are stepping in and basically saving educators from burnout by completely shifting the classroom dynamic. Think about traditional static learning, that one-size-fits-all approach that basically waits for a student to fail a test before offering help. But now, we have 2026's adaptive learning. Platforms like Realize It don't just sit back and react. They're analyzing real-time behavioral signals. By comparing response times and exact mistake patterns against millions of other learners, the AI actually predicts where a student is going to struggle before the lesson even begins. It proactively adjusts the material to fit their unique proficiency. How cool is that?
And the measurable impact on these institutions? It's honestly staggering. Enterprise education tools like isometric AI are actively reducing administrative workloads by 50%, literally half. And we're not just talking about back-office support here. Teachers are effortlessly designing professional-grade materials with zero design experience using tools like Canva's Magic Write. By stripping away all this massive friction, we're finally allowing educators to actually get back to the human element of teaching.
Which brings us deeper. Layer 2, institutional automated platforms. Zooming out from the individual classroom to the institutional level, we're seeing entire digital ecosystems governed by learning experience platforms, or LXPs, like Absorb and Cypher. And right here, there's a massive paradigm shift in assessment. We're definitely not talking about simple bubble sheets anymore. Modern automated grading systems use advanced AI to instantly score highly complex, nuanced assessments. They can analyze the construction of a written essay or the logic behind a multi-step math problem, and then provide immediate, detailed feedback in seconds. That's a task that used to literally cost human graders entire weekends. On top of that, navigating these massive institutional platforms has been totally transformed by a technology called deep search. This relies heavily on natural language processing to index not just the titles of documents, but the actual specific concepts buried deep within hours of lecture videos or thousands of textbook pages. When you combine that with predictive workflow learning, the system can anticipate a student's or even an employee's exact knowledge gap. It delivers the specific 2-minute clip they need to solve it before they even type a query. It's like it reads your mind. Now let's go further down. Layer 3, confronting algorithmic bias. To really understand the hidden realities buried in this code, we have to peel back the shiny user interface and deconstruct the 3D anatomy of how an AI actually thinks. It happens in steps. Step 1 is data imports. This is unstructured data, like video interviews or millions of text files. Step 2 involves selecting features, meaning the specific variables the system looks at, like a student's prior grades or their vocabulary. But step 3, well, this is where the danger lies: assigning weights. The algorithm decides how much importance to place on each feature. If the training data is historically skewed, the AI mathematically assigns heavier weights to traits that inadvertently reproduce systemic inequality. Let me give you a real-world example of this hidden danger. It's famously known as the Maggie bias. So testers gave the AI model Claude 3.5 Sonnet a prompt about a cooking competition involving molecular gastronomy. And the AI consistently selected a contestant named Maggie to have a hidden advantage. Why? Because the prompt required scientific precision and innovative techniques. The algorithm's internal weights unfairly associated those specific scientific traits with certain demographics over others, all based purely on biased training data. It's just this quiet mathematical assumption happening entirely behind the scenes. So what does this all mean? How are educators fighting back? Well, they aren't just blindly accepting these outputs, that's for sure. Teachers are now utilizing experiential frameworks and iterative prompt engineering to actively audit the AI.
Through a really collaborative process called dialogic reflection, educators analyze the AI's responses, map out the structural bias, and then design highly specific prompts that neutralize those hidden algorithmic weights. They're actively forcing the AI to ensure inclusive learning rather than just taking its word for it. Sinking even deeper now. Layer 4, privacy and facial recognition. Right into the systemic architecture. This is where the technology physically intersects with the student's body in the classroom, and we are facing a highly controversial balancing act here. On one side of the coin, school districts are investing heavily in AI-powered security cameras and facial recognition for automated attendance and physical safety. I mean, it's a legitimate, totally understandable push to secure the building. But on the exact opposite side, we have the massive, largely unexplored risks of continuous mass processing of biometric data from minors. And setting these boundaries, it isn't just some philosophical debate, it's a massive legal liability. Laws like the Illinois Biometric Information Privacy Act impose incredibly strict regulations on how physical data is captured and stored. As AI catapults schools into this wild, unexplored terrain, balancing civil liberties against the very real allure of automated campus security remains one of the most volatile layers of this entire ecosystem. It's an absolute tightrope walk for every institution involved. Finally, our deepest layer, Layer 5, the geopolitics of AI. We're zooming all the way out to the macro, foundational reality now, because none of the personalized learning we just discussed exists in a vacuum. It all brings us directly to AI sovereignty. This is a nation's capacity to control its own AI infrastructure. You see, countries have realized that relying on foreign tech for their educational foundations is a critical security risk. Consequently, nations are shifting their strategies to become layer specialists. They're focusing their investments heavily on one specific part of the AI supply chain just to secure their leverage in the global market. Because the magic of the AI classroom? It's severely bottlenecked by physical reality. The hardware supply chain is incredibly fragile. You simply cannot run an adaptive learning platform without massive processing power. And you definitely can't build those processors without navigating a severe critical minerals crunch and an unprecedented global shortage of AI memory chips. The entire digital classroom is completely dependent on raw earth. To secure these fragile supply chains, we're witnessing the rise of heavy industrial geopolitics. The European Union is planning massive AI gigafactories. We're seeing upstream shapers absolutely dominating the raw material markets, and sovereign nations scrambling to build their own foundation models. We all love to think of AI as this weightless, invisible cloud, but the reality powering a high school physics test, it's heavy, it's industrial, and it is deeply territorial. Which leaves us right here, staring at the foundational cost of dropping the world's most powerful technology straight into our classrooms. We've peeled back the layers today, from saved teacher prep time, down through algorithmic bias, biometric tracking, and all the way out to global supply chains. As this system becomes deeply entangled with both our schools and our global sovereignty, the ultimate question we have to ask ourselves is this: are we programming the future of education, or is the technology programming us?